I'm going to demonstrate the Faraday cage which we discussed in class. So I have my charged PVC rod here, and so when I bring it in the vicinity of the electrometer you can see the deflection of the gold leaf. Now here I have my lid to my thermos, which has a conducting metallic coating here, and its diameter is greater than the diameter of the disc, and so I can place it over the disc without the disc touching this cap, although the cap is coated with plastic and is non-conducting. Okay, so it's going to form a Faraday cage, and we know that, as we discussed in class, you can't have an electric field inside a Faraday cage. So now if I bring the conducting PVC tube here, we see no deflection of the gold leaf. And a little more dramatic demonstration would be as I lift and put back down the Faraday cage. So no cage deflection, cage, the deflection goes away. Here is an illustration of the electrometer with the thermos cap on it. So here's the casing to the electrometer, and this region here is the insulator separating the active part of the electrometer from the casing. Here's the thermos with its outer conducting wall, and the bottom of the thermos is actually a little piece of plastic, so I'm indicating that as an insulator here. So now what happens when we bring in the charged PVC tube? The PVC tube is negatively charged, so this excess of electrons here are going to repel the electrons in the outer surface here. And so those electrons are going to take this low resistance path to the other side of the thermos cap. And so the generated charge and electric field lines will look like the following. Here's the resulting static charge and electric flux density lines. So the negative charges on the PVC rod will have repelled electrons, and there will be a resulting positive charge on the surface of the Faraday cage here, that conducting thermos cap. And those electric flux density lines will be normal to the conducting surface here, otherwise we would not have a static condition, and then they will terminate on negative charges on the rod. Now the cap has a net no charge, so the positive charges here will result in an equal magnitude of negative charges over here, where the electric flux density lines will re-emerge, again normal to the surface of the conductor because we're in a static condition.